It's governed by laws. Have you ever thought about how gases behave? Air is a gas, it's all around us, and it follows specific rules called gas laws. These laws explain how gases change when we change their pressure, volume, or temperature. Understanding gas laws helps us predict how gases will act in different situations. Let's explore 3 important gas laws. Boyle's law tells us about the relationship between the pressure of a gas and its volume. This fundamental principle in physics and chemistry helps us understand how gases behave under different conditions. It states that when the pressure on a gas increases, its volume decreases, and vice versa. This inverse relationship is crucial in many scientific and practical applications. Imagine a syringe with its opening closed. The air inside the syringe is at a certain pressure and volume. When you push the plunger down, you increase the pressure on the air inside. This action forces the air molecules into a smaller space. What happens to the volume of air? It decreases. The air is compressed into a smaller volume. The air molecules are squeezed closer together. They have less space to move around, which increases the pressure. This is Boyle's law in action. You can see this principle at work in various real-world scenarios, from breathing to the functioning of hydraulic systems. The equation for Boyle's law is P1V1 equals sign P2V2, where P is pressure and V is volume. This equation allows us to predict how a gas will behave when the pressure or volume changes. Charles's law explains the relationship between the volume of a gas and its temperature. This fundamental principle of physics is crucial in understanding how gases behave under different thermal conditions. It states that when the temperature of a gas increases, its volume increases, and vice versa. This means that if you heat a gas, it will expand, and if you cool it, it will contract. Have you ever noticed that balloons seem to shrink on a cold day? This is Charles's law in action. The colder the environment, the more noticeable the shrinkage. When the temperature drops, the gas molecules inside the balloon slow down and move closer together, causing the balloon to shrink. This is because lower temperatures reduce the kinetic energy of the gas molecules. The equation for Charles's law is V1T1 equals sign V2T2, where V is volume and T is temperature. This equation helps us quantify the relationship and predict how a gas will behave when subjected to temperature changes. Section 4. Avogadro's Law, more air, bigger football. Avogadro's law tells us about the relationship between the volume of a gas and the number of gas molecules present. Essentially, it explains how gases behave when you change the amount of gas molecules in a given space. It states that when the number of gas molecules increases, the volume of the gas increases, and vice versa. This means that if you add more gas molecules to a container, the container will expand to accommodate the extra molecules. Think about inflating a football. When you use an air pump to add air into the football, you are actually adding gas molecules into it. As you pump more air into the football, you are adding more gas molecules. These gas molecules spread out and push against the walls of the football. This increase in the number of gas molecules causes the volume of the football to increase. The more gas molecules you add, the bigger the football gets. The equation for Avogadro's law is V1 over N1 equals V2 over N2, where V is volume and N is the number of moles of gas. This equation helps us understand and predict how the volume of a gas will change as we add or remove gas molecules. Section 5. Gas laws. They're all around us. Gas laws are essential for understanding how gases behave in our everyday lives. From inflating tires to understanding weather patterns, gas laws play a crucial role. By grasping the basic principles of Boyle's law, Charles's law, and Avogadro's law, we can better appreciate the science that surrounds us. So the next time you see a balloon, inflate a tire, or even just take a deep breath, remember the amazing gas laws that govern the air we breathe.